Okay, let's continue this story of looking at model outputs, the UVic Earth System Climate Model that we've been looking at with all its caveats. So let's zoom out of Africa, climate change, landscape change, vegetation change, and speculations about how it may have affected hominin evolution, diaspora. Actually, by this time, the time scale we are looking at, MIS 6, there is not so much evolution, it's just disappearance of the rest of the Homo species and the emergence of the Homo sapiens sapiens as the sole species into the Holocene. As far as we know, Floresiensis also disappeared by around 12,000 years ago. Unless they are hiding somewhere and not being found, which would be fun, right? Global aerial barren ground coverage anomaly. So again, comparing to 1800, at 110,000 years ago, 104,000 years ago, various MIS 5. Maybe we're already, we're in the 5 stages. Aerial coverage of barren ground derived from 100 and again the long time series. I don't want to read it each time. So here we are. You can see 110,000 years ago and 104,000 years ago, the barren land appears here in various parts of central Western Asia, Eurasia, towards the Middle East, and then expands by 104,000 years ago, which is kind of more details than we have been looking at, just focused on Africa. So what does this mean? Does this provide some guidance on the spreading of the hominins into Asia and not so early, not so far back into Europe and so on? So again, remember that we are using these to validate some of the things we already know, and then to add details in space and time to see if some of the more specific diaspora of the hominins can be explained with these kind of simulations. So there is our Skul Kafze Kabara site, and that also gets into this barren land. And the other thing to remember is barren lands may drive emigration from the site if there were already hominins present, or it may drive barriers. It may create barriers for pathways for species that are for our relatives that are trying to get out of Africa into other parts of Eurasia and Middle East, right? The next one is on global aerial barren land coverage anomaly in Africa. So we're back into Africa. 98,000 years ago and 90,000 years ago. This is again from the long simulation. So this is, even though I don't know why it said Africa, I hope I didn't screw that up. Let me just quickly check 612. Always tricky when I'm copying figures and not being super careful about it. Where are they? So this book congregates all the colored figures into one place, so I have to go and copy them and move them into appropriate places. So here we are, 100,000, 613, and no, okay, so I have the right figure, 612. So it is saying Africa, but we are still looking at global, so maybe that's just a typo because there's hardly any information on Africa here. So 98,000 years ago, barren ground aerial coverage difference, and this is 90,000 years ago. So you can see that compared to 1800, beginning of the industrial era, these places were there was more aerial coverage of the barren land. So these areas generally are already the Middle East and Central Eastern Africa, stretching into Afghanistan, Kazakhstan, Armenia, and those regions. Some of them have oil, some of them have nothing, and Iran has some oil, but you get into deserts which are barren in a vegetation sense, but obviously by then a lot of fossil fuel would have formed before this transition happens. In fact, there's an interesting story about how termites evolved around 100 to 120 million years ago, and then they started eating up hydrocarbons, so not much new fossil fuel formed after that. But that's digressing a little bit. Coming back to this area, you can again see here we looked at expansion from 110,000 years ago to 104,000 years ago, and this one is expansion of barren land, barren ground from 98,000 years into 90,000 years ago. The areas, I mean, the region covered is similar, so obviously this was pulsing up and down in terms of the barren land reducing in aerial coverage and then expanding again through these marine isotope stages. And there are some spots there, grid size noise here, for example Australia, which shows up here as well, and that's critical because Flores is over there, and we know that some sea level changes happened and migration happened over to this side, and there are also spots here around 90,000 years ago. To the extent that these are signals and not grid point noise in the model, they could either correspond to refugia or changes in position of the ITCZ, monsoons changing their, well, monsoons would have been there by then, because 10 million years ago we already had the monsoon. So those sorts of things may have been occurring over these places. Okay, so what else can I say about this? Yeah, so we're getting closer now. 613 aerial vegetation coverage anomalies in Africa 100,000 years ago relative to 1800. Broadleaf, needleleaf, C3 and C4. So again, aerial coverage, so we are here into Africa for sure. So now we are at 100,000 years ago, so I don't know if you're keeping track of the times. We are in Africa a little bit before, and then we have come back to Africa. We zoomed out, so we looked at climate change over Africa, vegetation response, zoomed out to global barren land, and then we have come back to Africa 100,000 years ago. So broadleaf trees aerial coverage, so these are now red colors in reduction. So this also can be, so there is a difference between reduction in vegetation versus expansion of barren land, right? So barren land is basically not much vegetation. They are not even grasslands or savannas or shrubs, right? Real barren lands. And needle leaves, again we are seeing similar signatures as we saw before. Fronts here in the Sahara Sahel region, and this East African region always shows up. I tend to think of it mostly as maybe shifts in the ITCZ, or remembering the present climate. This, as we mentioned before, this region has two monsoon seasons. One is the long season during March, April, May, when the Indian monsoon is having a pre-monsoon season as the ITCZ is trying to cross from the equator to the north, but gets split over the Indian Ocean, which we haven't discussed much, and has a short rainy season during the fall into monsoon, as India is getting out of the summer monsoon and getting into winter monsoon or northeast monsoon. So this region has these transitions that happened during the Pleistocene boundary East African edification, and it seems to have a signal in this model quite consistently in terms of vegetation changes, but surprisingly, obviously, doesn't show up in barren land changes. And South Africa also has signals in almost all times we have seen, because this is kind of a confluence region between the thermohaline circulation water, Indonesian through flow water going across, retroflecting and going back here, a gullus retroflection, and some of it is going around, going as rings and supplying the North Atlantic deep water formation site. So this region here is apparently very biodiverse, rich in biodiversity right now. All species of a particular kingdom of plant are apparently found here, according to what I heard from George Philander. So you can see that 100,000 years ago, broadleaf increased, needleleaf decreased. Here, both seem to have taken a hit, and here you get again this patchy distribution. This would be great if these are validated to these spatial scales, because they could really mean refugia of various kinds, not only for humans but also for various megafauna as well, which were serving as food for hominins. Okay, so C3 and C4 again both have shown an increase here, but this one is replaced, or at least C3 drops here and C4 expands here. You can see the scale here with respect to 1800. So again, this is a noisy place. So there is obviously some competition going on in the model between broadleaf, needleleaf, C3 and C4 plants. But this is also a hotspot going back to East African edification when grazers, browsers evolved, and this place got aridified and got converted from lush green forest into savannas and grasslands. So maybe I should find more literature about the variability of vegetation here in the modern times. Okay, so let me leave this podcast here and then conclude. We're almost at the end of this chapter, so let me come back and conclude with the remaining model simulations. Okay.